Hello and welcome to this demo session. My name is Eva Rowe. I'm Solution Manager for Airlines in the IBU Travel and Transportation. What I want to show you now is a demo of a concept that demonstrates the exciting innovation potential at SAP and how we can now support key processes at an airline based on our advanced technologies such as HANA. This demo is the result of a close collaboration between the IBU, PIO, and custom development. First, a little background. What do I mean with day of operations and crew recovery? Airlines have to face and deal with many disruptions. The challenges of day of ops is that very often things don't go as planned, caused by weather, unplanned maintenance, sickness, or other reasons. It's a challenge for operations to rebook passengers and reschedule aircrafts and crew members as quickly as possible and with the least overall effect on other flights. The costs of disruptions are enormous, and stranded passengers are not happy customers. A common problem airlines face when dealing with these challenges is the lack of transparency, tedious rescheduling that's often done manually, and the fact that compliance to rules might not always be guaranteed 100%. What we envision is one integrated platform that integrates planning with operations. For day of operations, there is an option to use a HANA-based engine that accelerates the airline system, or to engage with us to build a data hub that integrates all relevant operational systems, included with a BI layer. But it's not just for the BI needs, but also the basis for solving operational problems. As a next step, we can also provide a flexible rules engine, and as a final step, we can offer to actually solve the problem with optimization. We have a clear concept for this solution and can build it as a custom development project. And we can start wherever the customer has the greatest need, whether it be a data hub, passenger recovery, or crew pairing. We're flexible. Now in this demo, we will show you the recovery or optimized rescheduling of crew members after a disruption, which is really the most challenging problem to solve. So the solution we propose includes a holistic 300-degree airline operations cockpit or data hub, which provides real-time visibility and fast processing, flexible and fast rules engines, and optimized rescheduling. The result is the minimized impact of a disruption, which will make your customers happier, guarantee 100% compliance to all rules, and lower your recovery costs considerably. But now let's look at the demo. We'll be looking over the shoulders of John, who's a crew controller and needs to quickly find a solution when some of the scheduled flights are cancelled or delayed. John is quite happy because he has a new tool that gives him a lot of visibility and empowers him to do a great job. So here we see the operations cockpit with the different dimensions. As a crew controller, John's only interested in the crew area, and he works in operations, so his job is to recover situations when flights are delayed. He sees here the cockpit, and he's responsible for the airport base for all the crew members of the airport base Toluca. Currently he wants to look at the cockpit, and he's only interested in executing the plan for the next 48 hours. So he looks at a 2-day span. And this here is the current moment, and he looks 2 days ahead. And this is the time frame where he needs to solve issues. What he sees here is a number of cockpit crew members. He sees here captains and first officers. And here he sees the flights they're scheduled on, the flight number, arrival and departure. The green areas is really where they're scheduled to fly. The purple here shows that they're a dead heading, so they're actually being transported as a passenger to another airport. He sees here this officer is on reserve, and these officers with the gray and purple bar means that they're not to be scheduled. They're either on training or on vacation, but they're not available. We see here there are some violations that shouldn't have happened in planning. These two in the cockpit shouldn't be flying together because they're too inexperienced. But here John cannot change anything that's in the past, but he could settle that. Now, what is it, what's behind this? And he has the visibility here, but he can also check certain things, and he has a tool here, a rules engine, that's very helpful for him to make sure that all the rules are adhered to. So let's look into this rules engine. We see here the different rules, and there's different levels from leg level, so individual flight level, um, that rules like maximum time between flights, between one flight and the other. There's other rules that go to the duty level that are more complex. And then we have even more complex rules that are referring to a trip level, like the maximum number of days in a trip calculated by the home basis. So we see the data that needs to be checked, and the rules are getting more and more complicated. And of course, the most complicated rules are those that are responsible for the whole roster, that look at the whole roster, like here, maximum flight time in every 28 calendar days. So here we need to look at all the data relevant within 28 calendar days that would even go beyond a current schedule possibly. So there's quite some complexity of the rules here, and because John is a crew controller, he's only interested to apply these rules for the next 48 hours. Now there's different parameters that John can work with. The maximum number of legs per duties, for example, you could change that. You can sort them. Here we see the maximum number of legs per duty. Actually, from 5, he wants to change it to 3. He's saving it. So now he's actually changing the parameters of the rules for the next 48 hours. So this will be applied to the schedule. We can go back and look at the schedule and see how this affected the schedule. And we see here, only within the 48-hour time frame, we see a lot of all the trips that started in that time frame. We see a lot of violations here because of changing the rules. So we see here the maximum number of legs per duty was changed to 3, so we see all those 4 legs per duties show up at violations, and it's also indicated here that the maximum number of flights in a duty is not correct. So we change that back, but it's a very valuable tool for John, that he has a tool that automatically checks whether any schedule that he has created, any rescheduling he has done, whether any rules are violated or not. So this is a very powerful tool here that's at the disposal for John. So we set it back, everything is fine now. There should be no more violations other than the ones that were done in planning. Now John wants to look at some alerts, and this is something he wants to see whether there are any alerts that have come up. Yes, we hear here 10 new alerts were received since last refresh. This is not done automatically, but is given to John in John's control, so he can decide when he wants to deal with problems. And he might not want to deal with a problem every minute it comes in, but he can decide the point in time when he looks at it, and he decides now, okay, 10 alerts. Let's see what those are. He can see here different alerts have occurred. Flights here have been delayed, have been cancelled, Yeah, that's something he wants to look at. So he goes to the disruption, he goes to the impact analysis, and he can look in more detail here. Yeah, there's a number of flights. He can sort this too. Um, okay, he sees there's 4 flights cancelled, several flights have been delayed. This is something he wants to deal with now. You can also see what rule violations have happened, and he can see here, yes, there's a number of rule violations that have happened due to these cancelled and delayed flights. Here's a roster-based violation, some other violation like minimum time between flights. Um, Obviously here crew assigned to a non-operating flight. If a flight has been cancelled, crews can no longer be assigned to it. So this is definitely something he needs to work on. He could also look at some details of people. We see here the power. There could be some additional information that might help him in his job. But he decides, yes, I want to deal with these issues here. So let's apply them. He wants to apply these problems. Yes. So now he's applied the new affecting flights, the delayed and cancelled flight, and he can now see what is the result on my crew members. All these violations should now show up with my crew members, and yes, he sees here there's a number of crew members, of captains and first officers that are affected. Different violations that we have seen. Too inexperienced. We had seen those before. Non-operating fly. Here's a cancelled flight. Needs to be dealt with. Minimum time between flights, probably because of a delay. So there's a lot of things that he could deal with now manually. And he would have a powerful tool here to deal with it. But he has an even more powerful option. He can run the optimization. So that's what he's doing now. John can just automatically solve this issue and find the best solution for this problem. And he now wants to look at the solution. And now he sees on the lower line the original scheduling and on above the solved issue. So he sees here this was minimum time between flights, totally different scheduling here. There's another problem with the minimum time between flights, non-operating flight. So we see here the problems have been solved. We also see here that only the 20 crew members that were affected are still affected. This is something that would normally could hardly be done manually, that could not be done manually. So if he had to do this manually, he probably would have had to call in 10, 15, 20 other crew members to help out. But with this optimized solution, no one else was affected. So this is really an optimized way of dealing with the problem. When we look at it in more detail, we see that there's actually been a 10-way swap, something that manually is just not possible to do. So John's very happy with the solution. He saves the solution. The problem has been resolved. All cancelled and delayed flights have been dealt with. And he sees here his new schedule perfectly. He also dealt with the two inexperienced cockpit people here. So they're no longer violating the rules, and he's happy that he could do this job. Something else he has at his disposal is the simulation. Now this is something that provides a tool for John not just to handle disruptions that have already happened, but he can also prepare for major disruptions like storms that are clearly coming. This will give him the tool to prepare for that, to simulate. He can also use it to evaluate different aircraft solutions that might have been proposed by aircraft controllers. And he can see what the crew costing would be for that. Or finally, he can also use these simulation runs for tuning the optimization engine and the parameters, or for evaluating changes in crew rules. So this is also a powerful tool that can help John in his job. And finally, he also can look at different analysis, again, to evaluate, to fine-tune, to do a better job. So John is very happy with this new tool. He feels like he's very empowered. He has clear visibility, real-time data. He has the control, and he can also check whether he has a rules engine, flexible rules engine that he can fine-tune and that will automatically check whether all the rules are adhered to. And then finally, he has the optimization engine that will actually provide the best possible solution. So John's very happy with the tool, and he feels like he's fully empowered to do a great job.